Okay, welcome back, ninth hour. You picked up your packet from the table, and you also picked up your homework. So just letting you guys know that you only are completing the top half of the pink worksheet for homework. The topic that we're covering today is compound probability of independent events. Compound means there's two or more simple events occurring, hence why it's a compound. And independent events are two events independent of one another, so that the occurrence of one event does not alter the probability of the second event. You think of it alone, just like we ask you to do your work independently. So once again, compound means more than one. Independent events are two events. One of them does not alter the probability of the second event occurring. So some examples that come up, and you can read through this as many times as you need to for it to sink in. Two things going on. Tossing a coin or throwing a die is an independent, since each time the coin is tossed or the die is thrown, there's the same chance occurring. Either you get a head or a tail, or the probability is out of 6. Even if we have already tossed the coin 100 times, the next time we toss it, we still have a 1/2 chance or 50% chance of obtaining a head on the coin toss and a 1/6 chance of obtaining a 6 on the throw of the die. This little cartoon in the middle is key to kind of sum up that entire idea. So even though I've thrown the dice 10 times already, the next time I throw it, I will still have a 1 in 6 chance of getting a 6. What happened before doesn't change the outcome of the next toss or throw or whatever it is that we're talking about. So, to find the compound probability of two independent events, you're going to multiply the separate probabilities. So if there was the probability of heads on a coin, that's where you would get the half. You have a half chance of getting heads on a coin. And the probability of getting a 6 on a die is 1 out of 6. So you'll see it put together. So the probability of heads and 6 equals 1/2 times 1/6, which is 1/12. You need to remember the rules of multiplying fractions. You multiply numerator by numerator and denominator by denominator. The following formula can be used to find the probability of compound independent events, which is probability of A and B equals the probability of the A times the probability of the B, where A is the first event and B is the second event. Okay, so once again, if you need to go back through, basically you could have read this on your own. I just kind of chunked some of these ideas, but it's a really easy math problem to get. You just have to remember your fractions. So let's practice. We're going to do the first, first 3 problems together, and then the second page of your notes, number 4, 5, and 6. Once you've completed those, and you've completed them on your own as best as you can, then you're going to open up the Google Classroom document and check number 4 through 6. So, number 1, you spin each of the 2 spinners below just once, find the probability for the outcomes below. So you're looking at letter A, the probability of W, and the probability of 2. So the probability of W is 1, 2, 3, 4, 5, 6. There's 6 outcomes. There's 1 W. And you're going to multiply that by the probability of the 2. There's 1, 2, and 4 outcomes. My rules for multiplying fractions are numerator times numerator, which is 1 times 1. 1, 6 times 4 is 24. So your probability of those 2 things occurring is you have a 1 out of 24 chance of that happening. Letter B, probability of R and 3. Well, there's still 6 outcomes on the spinner, but now there are 2 R's. You could either simplify this now, or you could simplify it in the end. So 2 6 times 1/4, because there is 1 3 out of the 4 outcomes. I multiply this across. 2 times 1 is 2. 6 times 4 is 24. You will still never leave probability like this, 2 out of 24. You have to simplify these and reduce them to those terms. 2 divided by 2 is 1, 24 divided by 2 is 12. So that would be my final answer. Okay, probability question C. We're looking at the probability of spinning a B and 1. There are still 6 outcomes, however, there are 3 Bs. And because on letter B, I didn't simplify in the front, this time I'll simplify in the front. 36 is equal to 1/2, which is my probability of landing on a B, and my probability of landing on a 1 is 1 out of 4. So now I don't have to simplify in the end. So I just have my final answer there. All right, let's move on to question 2. 2 coins are tossed at the same time. Find the probability for the outcomes below. Probability of a heads and a heads. Well, you have 50% chance, or 1 out of 2 chance of getting a heads the first time, and a 1 out of 2 chance of getting a heads the second time. The first toss does not affect anything on the second toss. So 1 times 1 is 1, 2 times 2 is 4, and that is your final answer. The probability of tails and tails, it's the same exact thing. You have a 1/2 chance of getting tails, and you have a 1/2 chance of getting tails on the second roll. So this is equal to 1 or 10. And guess what? This last question is the exact same thing. Probability of heads is still 1/2, and the probability of tails is still 1/2. 1 times 1 is 1, and 2 times 2 is 4. If you're at the point where you think you got the hang of this, you could try number 3 on your own. If you want me to go through another example, then just continue to listen. So number 3, you spin the spinner and toss the 6-sided die below at the same time. Find the probability for the outcomes below. Probability of red and 1. Well, there are 5 outcomes on the spinner. Red occurs once. Times, there are 6 outcomes on the die. 1 occurs once. I multiply across, and I get 1. There is the final answer. Probability of a yellow, there are still 5 outcomes. There is 1 yellow times an even number. Well, our even numbers on that die are 2, 4, and 6, which is 3, 6. And if you want to, you could simplify that to 1/2 off the bat, but I'll just simplify in the end. So 3/30, I divide by my 3, and I get 1/10. So you might not know what your primary colors are, but hopefully you do. Letter C, the probability of a primary color and an odd. Your primary colors are yellow, blue, and red. So there's 3 of those out of 5 outcomes times an odd number. Your odd numbers on that dice are 1, 3, and 5. So 3, 6. And once again, you can simplify 3, 6 to 1/2 right away. 3 times 3 is 9. 5 times 6 is 30. I'm not going to leave it like this. That greatest common factor is 3. 9 divided by 3 is 3. 30 divided by 10 is 3. Or 10. Alright, I think this is a pretty easy topic that you guys can handle. Like I said, keep in mind, homework is only the half pink sheet of paper. I'll post those answers on Google Classroom. You're going to do number 4, 5, and 6 and check on Google Classroom. If there is any time left over, you could play your good old friend, the Plinkle probability game from a few days back. We'll see you guys tomorrow. Have a good day.